we use X as a unit now, I use Q as a unit. So these are variables of Q. So you should compare. It's just different notations. So I have f of x before. F of Q will be then your function. Okay, what I want to find out, so P is the measure in dollar, and Q is actually measured in the 1,000 units. So if Q is 1, then 1,000 units. I want to ask is, I want to find the average rate of change of the unit's price. I want to study I want to study is how the price affected by the quantity change. Okay, so I want to find average values. Now this didn't give you a particular interval, so it's quite general. Part B is actually give you a particular different Q. So what is average rate of change in the price when I changing my Q from 5,000 to 6,000? This is one change in Q. Okay, and then you have average velocity. And then the other is from 5,000 to 5,100, so you have another change, etc. And then C, I want is instantaneous rate of change at 5,000. Okay, so this is actually the quantity we studied before. What's the average rate of change? Well, you have two quantities, so this is the change of P over the change of Q. This means this is the average rate of change. If you change in terms of this, will be the difference quotient in my limits. So now I can just substitute back. Because my Q is this, I can just substitute back into my functions. So this first term, and this second term, over by h. Okay, so you just need to simplify, expand this out. Q squared minus 2qh minus h squared, and then plus q squared, and over h. And then you have a lot of terms we cancel usually. You actually will cancel all the terms without h. Okay, so you see that in the first term I have 4 small terms and 2 terms independent of h, and they will all cancel. And then I have 2q, I can take out the negative sign, so you factor it, I have a negative h, 2q plus h over h, cancel h, so you got negative 2q plus h. Okay? So this is the general formula, because I think in part B I need to apply a different Q. So this is a general formula when I'm changing from Q to Q plus H. Right? H is my change in Q. So for example, if I want to find out this, my Q will be 5,000, and the H will be the difference, will be 1,000. Right? So now the second part. Okay? When I'm doing 5,000, so that means is Q is equal to 5. Now not Q is not equal to 5,000 because my unit is unit in thousand, so you should change back. And what is H? H is the difference of this, so it's a 1,000. Okay? So therefore, the difference between them, I can now substitute back into my formula. I just compute the average rate of change is negative 2q plus h, negative 2q plus h. So therefore I get negative 11. Okay. The negative means decreasing. The price actually decreases because it's demand curve. Okay. If you increase the quantity from 5,000 to 6,000, you will decrease the price by $11. Okay. Then you can change, you can do the other interval. So this means is Q is equal to 5. And what is the H? H is different. So it's 0.1. Okay? Right? In thousand, so it's a 0.1 change. And you substitute there, so you're changing from 5,000 to 5,100 units, then the price will drop by $10.1. And similar for the last one is Q equal to 5, and the delta will be even smaller. There's a 0.01. Substitute the formula, you get a small increase. So it seems they approach to 10. Okay? The instantaneous rate of change, that means it's not average, you have to take the limits. Okay? That would be the instantaneous. When you see instantaneous, you have to consider limits. But in the part A, I already simplified this one. So I'm going to use this. So in the part A, so this is 2A plus H. Okay. This is by part A. So you don't need to do the calculation again. And you compute this limit, A is independent of H. You plug in H equal to 0. So therefore, negative 2A plus 0, so it's negative 2A. Will be the instantaneous rate of change. Okay? Now I actually compute A is 5,000, so A in fact is 5. Okay? You don't have H because it's instantaneous. H will tend to 0. You only have one value. So therefore it's minus 10. Okay, that agree with the above calculations is approach to 10. So what the meaning of this? That means so you have a demand functions. Now you are at the quantity 5,000. If you want to change, you want to increase. Okay, and you increase slightly. Okay, you are not increase very large amount, but increase slightly at 5,000. Because when you want to make a decision, is that do I want to change or not? I want to change it, increase slightly. That means instantaneous, then the price will drop about $10. So that is the conclusion of those things. Okay? If you learn, so later we'll have examples, this is precisely the terminology in economics called marginal. Marginal means anything you change with 1 unit, and what is the quantity changing. You can have marginal cost, marginal revenue, marginal profit. Marginal precisely is the derivatives. Okay? Before we talk about the marginal, I may not have time to go through the marginal, so I will do it on next Wednesday. Next Wednesday is the science for both do the midterms, so I certainly have time to do it. We'll talk about the graph of the derivatives, the tangent exists or not. We do it for continuous, but now we want to study in more detail, not just a jump. Okay? Remember that F derivative exists. That would imply F is continuous at the point. So we mentioned this. So the derivatives, the tangent, is actually stronger conditions of continuous. You have to be continuous to have a tangent. If you do a jump, you cannot touch or fit the curve by a straight line. Okay? Because the jump, the curve already doesn't look like the straight line. Okay? So therefore, given the functions, if the derivative does not exist, then that means the function is not continuous, so there's a discontinuity. Okay? For graph A, this is a graph A, so you have 3 points, which is not continuous. So therefore, at this 3 point, x1, x2, x3, because they have jump or infinity or removable discontinuity. You cannot draw, you cannot consider any tangent at this point. There's no tangent at this point. No tangent at this point. No tangent at this point. Right? Because they are not continuous. Tangent have to be very smooth. There's continuous and no sharp one. Okay? Now that one, the x4, is called the vertical tangent. Okay? Now this is the case when you learn in the high school that the slope of the tangent, the vertical straight line have undefined slope, right? Vertical, or sometimes people are using infinity or negative infinity. So this is precisely this, my derivatives is actually going to infinity. You have a tangent exists because it's vertical, but the derivative does not exist because slope is infinity. So the slope is undefined, okay? In fact, it's going to infinity. So in fact, it's infinity, plus or negative. Remember, I have a limit does not exist but can be infinity. Or you have something called the cups, or the sharp rod. So like this is a cup. Okay? You can fit or touch the curve very nicely by a straight line. That's not you need one. So this one, this sharp point, for example, like this may just touch one point, but then this is another line should not touch one point. So you cannot find a unit line to be a tangent. So no tangent on this point. Okay? The corner and the cups is quite similar. It's also called the sharp point corner here. One is they are curving down. The limit actually can be it does not exist but can be infinity. But anyway, they have a sharp point, so you also have no tangent here. So then, in all this case, you cannot compute the derivatives. That means the limit does not exist. Does not exist. Or this notation F derivative does not exist. Does not exist, so you don't have a slope or a tangent, there's no tangent, and they should be one of this graph. So it's important for for us to finding the derivatives, especially you want to exclude this case. So this case probably have no meanings in practical situations. Suppose this is your Porphyry curve, then the jump probably don't want to study. But say, for example, if this is my Porphyry curve, then I know that it's increasing, right? And if you're looking this, this must not be the curve Porphyry. Suppose it's a cos function. You have a minimum here, right? And of course, you want to find is a minimum cos. That's why it's also a minimum. So when we try to study it, because we want to know it's a maximum minimum of the curve. Okay? I give you this particular example, so you have absolute values. So that would imply x equal to 3. So therefore, the absolute values functions will be very typical. The absolute value is a V shape, it's a corner, right? So at the corner, certainly it's not differentiable. You may change the corner, so switch the corner. So in particular, you switch the corner to 3, so the graph is like this. Okay? So therefore the function is not differentiable at this point. There's no tangent. So f pi 3 does not exist. So there's a corner at x equal to 3, and the derivative does not exist. Okay? Depending on the other case, this one, I have a problem dividing 0. So when x minus 4 equals 0, I get x equal to 4. Okay? This is a rational function. That would rational function have a vertical asymptotes. And when you make the point equal to 0 of the denominator, the derivative also not exists. This is because the vertical asymptotes is like this. Right? So this is my f x 1 over x minus 4. You have the discontinuities, the vertical asymptotes. It's actually infinite discontinuity. So therefore, f pi 4 does not exist. Right? Even the function is not defined at 4. So it's not continuous. If not continuous, not defined, you cannot talk about the tangent. So this is a very bad case. This one, this function, is actually showing you the cups at x equal to 0, and the derivative does not exist. I want to draw this graph. Because of the cube and square, make it not straight line, and make it this. So this is y equal to 3x squared. So therefore, this is a capsule. It's continuous, but the derivative is infinite. So still, the derivative does not exist. Okay? So you basically have the types like this. Okay? So I stop here. I still have a couple of slides of these lectures, and I will go through on Wednesday. And Monday is midterm, so don't be late. Please bring your photo ID to remain checked.